Everyone, this is Derek, and this video is about differentiating the natural exponential function, which is e to the x, which is our absolute favorite function to differentiate because the derivative of e to the x is e to the x. It's the only function that does that. It is its own derivative. We can make it more complicated. So the same as we saw with the natural log, if the exponent, which is sort of the argument in this, is a function, then we get the original, and then it'll be times the derivative of the function up in the exponent. So here we go with an example. This one is actually, so we got like a couple of just have regular polynomial terms we can just do our power rule on, and then this piece we'll use our chain rule form. So here we're just going to have f prime of x. So 3 times 3, that's going to give us, excuse me, 9x, and take 1 off, so squared. And then 1 times 4 will be a plus 4 right there. And then we're going to have here, I'm just going to write down the -2 for now. And then we'll get the original function back. So that's this e to the -4x. And then that will be times the derivative of the exponent, so the derivative of -4x. So then that will be times a -4. So then just writing that out a little bit nicer. And then right here we'll have -2 times -4, so that's going to switch that up to a +8, and then our e term. Okay, so this one, e to a function up here, but this time we're going to find f prime, and then we'll find f double prime, which will add kind of a layer to it. So f prime, not too bad. F prime will just be the derivative of the exponent. So I'm just going to write that in front this time. That will be 4, so in case you can't see, it's 2x squared minus 5. It's that exponent. So 2 times 2 makes 4x. And then times this e to the 2x squared minus 5. So that's our first derivative. So now we would need to do our second derivative. So if you notice, our first derivative is now a product rule. So we'll do kind of a u and a v situation. So u is going to be the 4x. So u prime will be a 4. And then v is going to be this piece. And then v prime is going to be the derivative of this piece, which, remember, we just did it. It's right here. This was the derivative of that piece. So 4x times e to the 2x squared minus 5. So now we do our u prime times v, and then plus u times v prime. So that is going to give us, actually let me scoot down here, we'll have a little more room. So 4 times this, and then plus 4x times this. And then here, this will be 4x times 4x. I'm going to write that as 16x squared. And then, oops, sorry, this is actually f double prime, my bad. So then here, there is this common factor of e to the 2x squared minus 5. And so the way they wrote it was with that common factor factored out. But then they didn't factor on the polynomial part of this. And I think, kind of depending on what you're going to do it, this could be a pretty convenient form to have it in. So I think they were just cleaning it up a little bit. Okay, so for number 3, we have 4e to the -3x, and then it's times the natural log of 6x. So that's, again, going to kind of be a product rule. So let's go, u is going to be the 4e to the -3x. So then that's going to make u prime be just what this is, and then times the derivative of the exponent. So the derivative of the exponent will be a -3. And let me write it out. And then this is going to be times negative 3 for that derivative. So that means my u prime is going to be negative 12 and then e to the negative 3x. V is going to be the ln of 6x. So let's see, v equals natural log 6x, and then v prime. So remember that comes out 1 over the argument, and then times the derivative of the argument, which in this case would be 6. So those would cancel, and our v prime is 1 over x. And then here's where we do those two multiplied together plus these two multiplied together. And I'll go ahead and write all that out and come back. Okay, so let me talk through what I did here. So I went u prime times v, so that's right there. And then that's our plus u times v prime. And so this just gave us this in the numerator and then that x in the denominator. So then to get this, you can kind of see there is some common factor type stuff going on here. So they did clean this one up a little bit. They got a common denominator, and they did that. Since this one has a denominator of x, I can just go x over x right here. So I'm just multiplying it by 1. But what that lets me do is it lets me write it this way. That. So this will be negative 12x e negative 3x ln 6x plus 4e negative 3x. And then all of that is now over x because of that common denominator by slipping that x there. And so then what they did was they took and they have this e to the negative 3x, the exponential part. So just like in the last problem, that's going to be our common factor. So f prime of x. And it's a little funny to have the negative in front. So let me rewrite. I shouldn't try to rewrite that order. So there's that with that e to the negative 3x factored out front, and then you can see the negative 12x ln of 6x is here, and the 4 is there. The thing I was thinking about was I might reverse the order just because it looks a little bit nicer as 4 minus that rather than minus that plus 4. Same thing though. And then that's all over x. Nothing reduces, and so that would be our final.